Hi, welcome to Solve for X. My name is Lungelo Gonene, and if you are watching us on Facebook, please follow us, and if you are watching us on YouTube, please subscribe to our YouTube channel. Today I'm not going to take your time. I just want to help you with that difficult question of first principle. So we are going to derive f of x equal to square root of x using the first principle. So the first thing to do here when you are given this to derive it, firstly you have to derive this using the derivative laws, or the laws of derivatives. F derivative of, firstly you say f of x equals to, according to the laws of exponents and sets, this can be written as x to exponent 1 over 2. Okay, so f derivative of x would then be 1 over 2 times 1 would be 1 over 2 x 1 over 2 minus 1. Therefore, f derivative of x will be equal to 1 over 2 times x to exponent negative half. Then this can be written as 1 over 2 times 1 over square root of x. This can be written like this. So if it's like this, 1 times 1 will be 1, 2 times root x will be what? Will be 2 root x. So that's what we are going to have. Okay, so then let's see, using the first principle, f derivative of x equals to f x plus h minus f of x all over h. So when you using the first principle, f derivative of x equals to limit as h approaches 0, f of x plus h minus f of x all over h. Okay, so when you, this is h, when you are writing f of x plus h, don't change this and write it in this form. Just take it like this. So it will be limit as h approaches 0. So you say square root of x plus h minus square root of x, okay, all over h. Okay, so after you say f derivative of x equals to limit, since h approaches 0, so here you are going to say f of x plus h minus square root of x all over x. Multiply this by 1, right? When you multiply it by 1, you haven't done anything. So basically, after, you are going to say limit as h approaches 0, square root of x plus h minus square root of x all over h, multiply by, change this 1 and write it as square root of x plus h plus square root of x, okay, all over square root of x plus h plus square root of x. So this over that, it's still 1. So why do I choose this? Because our focus is there. So the reason why we wouldn't take h and make it h over h, it's because our focus is there. That is what we are solving. Okay, all right, so limit h approaches 0, so square root of x plus h times square root of x plus h, square root of x plus h times square root of x plus h is equals to x plus h, x plus h. Why? Because square root of x plus h squared, this and this will go, right? Then you remain with that. So square root of x plus h times square root of x, it's plus root x plus h times root x. So negative root x times that will be negative root x plus h times root x. So negative root x times root x will be minus x. Okay? And then from there, you are going to say, over, okay, sorry. Here you are going to say h times root x plus h plus root x. Okay? You're just going to do it like this. So I want you to notice x will go with negative x. And then root x plus h times root x will go with this, since there is a minus sign there. This and that will go. So you remain with h. So limit, since h approaches 0, h over, since it's the only one that you're left with, over h into root x plus h plus root x. So then x and x will go out for lunch. Then you remain with f derivative of x equals to 1 over, remember these and these, they reduce to 1. I want you to eliminate this idea of saying they cancel out, but rather say they reduce to 1. Okay? So root x plus, notice I didn't write limit as h approaches 0 because now h has become 0 now, right? Plus square root of x. So then let me just rewrite it here. F derivative of x equals to 1 over, square root of x plus 0 plus root x. So this is 0. So basically you have 1 over root x plus root x. So therefore f derivative of x equals to 1 over square root of x plus square root of x is 2 square root of x. That is your answer. Thank you very much for tuning in. See you again next time. Please don't forget to subscribe and check us on TikTok. Thank you.